Hello everyone, my name is Naveen Kumar and I'm a solution architect in Edge business unit at Dell Technologies. Today I'll be talking about Edge data management, its architecture, and the importance of virtualization in it. So let's get started. This is a standard disclaimer. Take a peek and I guess we can move forward. So these are the topics I'll be covering in today's presentation, and I'll take questions at the end on the side, given the interest of time. So what is edge data management? Before we talk about that, I want to talk briefly about edge. So there are two main reasons why edge exists. One is performance, and the second is cost. So when we talk about performance, we are talking about real-time and near real-time outcomes. And when we think of cost, it's more to do with how we convert the data into information and store it long-term, whether it's cloud or you have a on-prem location. So now when we look at this data of edge data management for edge actually, that in next 2 years, there will be 800% growth in the number of applications that are going to run at edge. And amount of data processing that's happening at edge right now is around 10%. This will go up to 75% in next 3 years. So how do we deal with this? To manage this data properly, we need to have a edge data management. And that is not a want anymore, it's a need. If you don't do it right, it will be almost impossible how we would track this data. Now, there are multiple things need to be considered when we are talking about edge data management. And there are a lot of challenges that we need to deal with at the edge. So some of them cannot be solved with virtualization, but definitely the ones that are highlighted in the box can be. So we will talk a little bit more about them. Now, some of the folks make questions like why Kubernetes or VMware Tanzu and not VM? To simply put, Kubernetes or containers, when we say, is the VM of the new world. They are the epitome of virtualization in the given time, or in the current times, actually. So let's look at each of these challenges, the ultra-low latency, optimal use, and continuous availability in detail. Now, when we think of latency, irrespective of what solution you're trying to build, performance has to be an inherent part of the architecture because given my experience in the industry, I have never seen a customer coming back to me and telling why my system is performing better than what I asked for, right? So it has to be taken seriously in every architecture. So the first building block that we're going to have for architecture is we have to ensure that latency is good. Now, how do we deploy Kubernetes in a way that we get the most optimal performance out of it? And the answer is bare metal. But I would like to point out here that Tanzu, in the recent data that I've seen for Tanzu, TKG, they have talked about reaching or getting the same comparable performance as what you see with bare metal with Tanzu, which has a hypervisor as ESXi. So if you're not using ESXi or if you're not using Tanzu, I would suggest you start with bare metal and deploy Kubernetes on top of that. What do we get out of it? A better performance and a faster response. So that is how we deal with the first challenge of low latency or the requirement of low latency. Now, when we talk about optimal use of resources, this is a complicated topic in a way because resources are scarce at edge at all verticals, whether it's manufacturing, retail, oil and gas, or telco. So we have to make sure that we use them properly, and Kubernetes does provide some insight into that, or does help in that case, because they do have a granular control on the resources that are allocated to the containers. Now, but the question is, how do we know what resources do we need to allocate? To find that out, there is a two-step approach that I suggest. One is synthetic workload. That means pre-production workload optimization effort. You run a simulator of the app or application that you are trying to install, and make sure that you profile the workload based on that and assign resources to containers based on what your workload is. The second approach is production workload, where you just deploy the workload directly and then decide, oh, is the resources I assigned are good enough or not. The issue with the second approach is it doesn't scale because you never know how the workload is going to be in next 6 months. So what I'm suggesting is people should have a combination of these two workload approach, not just one. So it's not an either or, it's an and situation. So now you take these two optimization efforts combined with the machine learning and feed this data from these two sources into machine learning, so you have a continuous improvement in terms of allocation of resources. So what's the takeaway for this? Efficient deployment of applications on at the edge. Now the third challenge, continuous availability. High availability has been there in the market, and I think everyone knows about it. But at edge, we just don't need high availability. We also need continuous operation. That means the data has to be available at all times, irrespective whether we are doing an upgrade or maintenance and other operations as well. So how do we achieve that? Kubernetes is already built for this, or the container orchestration platforms are generally built for this. So this is already an inherent feature. You just have to set it up correctly. So that's how you deal with continuous availability. Now, this is the high-level architecture of edge data management that I'm suggesting that how people should look at it. Now, this slide is very busy, and there's a lot to talk here, but I'll try to keep it brief and talk about the important pieces. So first is a convergence platform. Now, it could be a platform or it could be a layer, where all the data from the edge devices are coming in, and now, once the data comes in, you standardize the format, and you also standardize the protocol through which it will be going to the next layer. In that case, you know all the data is structured. So there are a lot of third-party applications available, or you can build your own. The second is image and video collector and inferencing layer. This can be dealt through GStreamer or OpenCV or OpenVINO. There are a lot of applications available there, and the data could be sent to the streaming platform. Now, why are we talking about streaming data platform here? This is, you must have heard of Kafka, and there's something similar, Pravega. So high performance and scalability is at the heart of event-driven architectures. And these platforms are built on the basis of that. So there is absolute need to have a streaming platform if you want to build an agile system, edge data management system. Now, the other important aspect of the solution is data sanity check and data correction mechanism. What I mean by that is the loss of data during transmission is a thing in the real world. There's no such thing as perfect, correct? So the system should have the capability to deal with the data if it's partial or it's incomplete. How do systems make sense of the data? So you need to have a layer within your edge data management that can make sense of the data that's partially complete. So special emphasis have to be paid. Special emphasis has to be taken care of. Put attention to sanity check and data correction mechanism during the deployment and development. So what are the takeaways from this? You need to have Kubernetes. You need to have a container orchestration platform. You need to have an event-driven architecture. You need to have a streaming platform. And you need to have a mechanism how to deal with incomplete data at edge. So these are, I can talk more about this if folks are interested one-on-one. Please feel free to stop by at our booth, which is 902 Dell Technologies, and I'm happy to answer any questions related to that as well. Do visit our Discovery Park as well. This is a place to relax and a place for free drinks and beverage snacks as well. Any other questions? Thank you.